a solar panel, a battery, and then in the middle we have the MPPT. So what is this MPPT and how it works? Well, I don't know. So, bye! Just kidding guys, let me explain. Now MPPT, like this project here from a previous video, stands for Maximum Power Point Tracking. So basically this device, like this one, will track the power output of a variable power source. It has to be variable because if it were to be like a power supply like this one here that I have here in my workshop, which can give a steady output of voltage and current, you wouldn't need a MPPT. We use this device with variable power sources such as a solar panel, maybe a wind turbine, and who knows what kind of generator we have that has a variable output of voltage and current. And that's what I want to explain in this video, how this MPPT controller works and how we would make one for a future video. That being said, let's get started. What's up my friends, welcome back. In order for you to understand why we need an MPPT controller, you first need to understand what is a variable power source. Well, for example, a fixed power source would be my power supply that I have here in my workshop, because I can set the voltage and the current to be the maximum value that I want for my battery, and this will give that maximum power and it will be a constant value. It won't change because this is a power supply and it uses the power from the grid, so I don't care if the values will change because I know they won't change because that's how it's designed. But the variable power supply would be something like a solar panel or maybe a wind turbine or a generator that you have and it's powered by a motor, for example a gasoline motor. So in case of the solar panel, the output will be variable because you don't know if you will have a lot of sun or maybe it will be cloudy that day or raining, so the voltage will drop, or maybe outside is very cold and the solar panel, the output will be affected by the cold temperature or by the hot temperature, and you don't know if there will be some shadow, so maybe half of the solar panel is covered but the other half is not. So depending on those variables that you don't control, both the voltage and the current value from this panel will be different at any time. So that's why we need this controller that can take the decision of what voltage and what current we need at any time, so the power that we are getting out from the panel will be always the maximum power. So that's what a variable power source would be. A solar panel, wind turbine, and so on. So in order to understand how this MPPT works, you have to understand that power is equal to voltage times current. And remember this, power, voltage, current. But before I go into this, let's just hear a small message from our sponsor, PCBWay. Hey guys, PCBWay is sponsoring this video, and let me just tell about their services. For example, look how awesome their prototyping PCBs are. And you can get these for only $5. They are so professional and they will make your project work a lot better. And to order such PCBs, you only need a few minutes on their website, where you can select any configuration that you want for your boards. Along with that, you can also order the SMD stencil for soldering the components using solder paste. And you can also use their services for flexible PCBs and create some unique projects. And if you want to make your project start to finish, you can get the PCBs assembled together with the mold injected part, or maybe 3D printed, metal parts, or other CNC services, all with PCBWay. Okay guys, so we can continue. So I was saying that it's very important to know that power in electronics is equal to voltage times current. So if you want to get the maximum power, you need to have the maximum values of voltage and current. Now the maximum value of voltage is given by the panel, and let's say that is 25 volts. And you can get a current of maybe 2 amps, and that equals to a power of 50 watts. If you want to get more power from that panel, let's say that you want to increase the current. But we know in electronics that the more current you draw from a power source, the voltage will drop. And in order to see that phenomenon, let me just show you what happens with my power supply if I fixed a fixed voltage and then I increase the current. You will see that the voltage will drop. Okay, so you will see how easy it is to understand this. This is my power supply. I set the voltage to 5 volts and the current maximum output of 1 amps. I activate the output, and to simulate the output as a load, I'll add just a resistance like this one. This is of 15 ohms. So obviously, if I add this to the output, 5 volts divided by the resistance, which is 15, will equal to around 300 and something milliamps of current. So I add this to the output, as you can see, when I connect it, exactly 300 and something amps of current, milliamps of current are flowing, and as you can see, the voltage is still 5 volts. Now if I increase I decrease the resistance, so I increase the load. In this case I add 2 of these in parallel, so now the resistance is half of 15, so 7.5 more or less. as you can see, the current will be double. So instead of 300 milliamps, we have 600 milliamps. But since I haven't reached the maximum value yet, which in this case will be the maximum value of the solar panel, the output is still 5 volts. So we can still increase the power output, which is the multiplication between the current and the voltage, but we can do that till we reach the maximum current value, which is 1 amp. So let's see, if I put 3 of these in parallel, what will happen if I surpass the maximum current value. Now, because with 3 resistors in parallel, the current value is still not surpassed because we have 300 times 3, in this case will be 900 milliamps. What I will do is to add 4 of these resistors in parallel, so we'll get more than 1 amp of current. Let's just see that. So here I have my load, and now I'll connect the output and pay attention to the voltage value, also to the current value, but more important, the voltage value. So I connect the output, and as you can see, the current is limited to 1 amp, but now the voltage instead of 5 volts just dropped to 4 volts. And that's the problem, because now the output, the maximum output will be 4 volts multiplied by 1 amp, in this case is 4 watts. But we can get even more than that just by lowering a little bit the current value. For example, if the value were 900 milliamps and the voltage will still be 5 volts, we will have 5 volts multiplied by 900 milliamps, which is 4.5 watts. So as you can see, just by changing the current value and the voltage value, we can still increase the power. In this case, the power is limited to 4 watts, but we can get to up to 4.5 watts just by lowering a little bit of current and still keeping the voltage at 5 volts. I hope that's understandable, and that's what an MPPT controller will do. And now I can explain you how it works and how it will do that process. Okay, so that was easy to understand, I hope. So basically, if your power source is limited in current, maybe you can just change the output of the MPPT that goes to the battery, so you will have less current but still keep the maximum voltage and get the maximum power output. So basically, to understand how MPPT will decide that, will take the decision, we have a graph like this one here that I'll try to place on the screen. And on one axis we have the current, and on the other axis we have the voltage. So obviously, if the current value is very, very big, the voltage will get very low. So the power, which is voltage times current, it will be very low as well. But at the same time, if you lower the current too much, even if you have the maximum voltage, which in my example was 25 volts before, you still get a low power, because 25 volts times a very small current, maybe 100 milliamps, still equals to a very low power. So what the MPPT will do is basically just trial and error, and each time it measures the current and the voltage, and with that calculates the power. So when the power is lower than the previous power, it will change the values of the output, so it will get back. So basically, it will move along this graph just by changing the current and the voltage till it gets this point, which is called the maximum power point of the MPPT, and that will be the maximum power output. If it detects that the current value, by getting it lower, the power increases, it will lower the current. But if it detects that by increasing the current, the power will get higher, it will increase the current. So basically, inside of the microcontroller, we make some decisions. We measure the voltage and the current with some sensors, which I will show you in just a moment. And just by making small changes in the code, we increase the current value, and if we see that by increasing it, the power also increases, we keep going. But when we notice that by increasing the current, the power is decreasing, we go backwards, and then upwards, and then backwards, and just like that we stay in that perfect point, which is the maximum power point. That's what the MPPT will do anytime you connect a variable power source and then you connect it to a battery to charge it. Okay, and another thing that I have to explain to you is the difference between MPPT and PWM controller, because we also have PWM controllers, which basically sets the voltage of the battery, in this case, for example, 12 volts, and then just measures the current and change the PWM output in order to gradually increase the current, because some of these batteries have a label with the charging process, and you have to have a very specific charging process at the beginning with the bulk, absorption, and then the float state. That's what I did in my previous MPPT power controller. That's why later we'll talk about some comments that you left in the comment tab of that video. You were saying that that is not an MPPT controller, it's just a PWM controller, and it's a mix of that. But you have to understand that the most important part is the voltage of the battery as well. Because in order to charge a battery, the voltage of the panel must be higher than the voltage of the battery. So if the battery, for example, has to charge to 14 volts and you only have 10 volts, you will never be able to charge the battery because the voltage of the panel is lower than the voltage of the battery. And by potential difference, the voltage from the battery will try to go backwards to the panel. Usually you have a diode to prevent that, but you need to have a high voltage from the panel than the voltage of the battery. That's why usually at first when the battery is very low voltage, we won't be in MPPT controller, won't find the maximum point because the voltage of the battery is so low that we have to decrease the current so low that the voltage will be the maximum. In this case it was 25 volts. So with 25 volts you can charge a battery of 10 volts. Actually you can decrease it to only 10 point something volts if you need it. So maybe the controller won't be able to get to that maximum point, but after you reach like 12 volts or 13 volts, which is more or less the nominal voltage of the battery, you can get into MPPT mode. So some of these controllers are a mix between PWM and MPPT, and the controller will decide when to use MPPT or when to use PWM, because depends on the battery, depends on the charge that you have, and so on. For example, the lithium-ion batteries or the LiPo batteries will have a curve like this when they are charging, and the lead-acid battery will have a curve like this. And some of these lead-acid batteries will require a bulk time, absorption, and then a flow time, so you have to make a ramp, which is not MPPT. Once you have the ramp, you can float it or maybe make the absorption time, which could be MPPT, and then you just maintain that voltage using MPPT or any other controller. So usually these devices, these drivers, will choose on which kind of controller they will use in each time. So it's better to have an MPPT, but it's a lot better to have a mix of those two. So that's why I told you that it's very important the difference of the voltage of the battery and the input. Because it's very interesting that I wanted to tell you that if you have a battery that is 80% discharged, so it's almost empty, it will charge a lot faster than the battery that is only 50% discharged, so it still has half of the charge. That's because the voltage difference between the input, which is 25 volts, and the output, which in this case, let's say that 50% is 7 volts and 80% is only, I don't know, 5 volts. These are just imaginary values. Usually in a battery is not like that, because if a battery reaches 3 volts or 4 volts and it's a battery of 14 volts, that means that the battery is dead. But as you can see, a battery that is 80% discharged, even if you have to put more charge into it, because if you think about it, the larger is the gap between the solar panel and the battery voltage, the more current will flow from the panel to the battery. So it will charge up a lot faster. So if you have a battery which is a lot more discharged, sometimes it will charge a lot faster than if you have a battery that is only 50% discharged. That's why usually the manufacturer will recommend you to discharge the battery up to 80% or something like that. In case of a Tesla or any other electric car, for example, usually they recommend you to discharge up to 80% and then charge the battery. So that's very interesting to see, because usually by logic, a battery that is only half discharged will charge a lot faster than a battery which is already 80% or almost fully discharged, but it's vice versa. Oh, and another thing that we have made in that project of the MPPT is that usually these kind of devices have preset points. So you can select what type of battery you are charging. If it's a lead acid battery, if it's a LiPo or a Li-ion battery, you can select that in the menu, and it will have some pre-adjusted points, so it will know from what voltage to use a PWM signal and just make a constant current value, and then it will know from what voltage up to the maximum voltage to use MPPT, and so on. So usually they have preset values, and that's what I've made in my tutorial. So when we were into the ramp value, we just use PWM to increase the current gradually, and then when we are into the absorption and the float mode, we were using MPPT. That's another thing that you should know, that usually these devices have some preset points that are stored into the memory depending on the type of battery that you are using. Okay, so now I want to talk about my version of the MPPT controller, which was this one, and by now it's all destroyed because I had to take a lot of parts out. And we will talk about this one because actually I've already made the PCB for that project, but it's not ordered yet. I will order to PCBWay, then assemble it, make some tests, and if it works, I'll make the video. And I say that because a lot of you are telling that I always show what project I want to make, but I never post it. Actually, from the time that I select the project till I make it, maybe 2 months, 3 months will pass. So just have patience, because each project that I'm talking about will finally appear on my channel, but it will take some time because it's not that easy to make a project. I've already explained that in a previous video. Actually, that's why I'm making this type of video where I take the camera and explain it to you, because a lot of you guys, actually that was the first time that I have more than 1,000 comments on a video, and a lot of you commented that you really enjoy these kind of videos. Not without a script, without too much editing, just me talking, so in that way you can know me, and also it will be a lot more natural for you to understand the projects and what I want to tell you, because, well, I'm a little bit more natural and also funny and pretty nice guy. Let's talk about my prototype of the MPPT, and that's because the next version will be with an ESP32. We have a lot more memory, more bits, 32 bits, so more speed, and we also have Wi-Fi. And with Wi-Fi we can connect that to a network and also show that value on your screen, on your app. So usually the nowadays MPPT controllers will connect to Wi-Fi because you want to know how much charge from the solar panels are going to the battery, how much charge you have stored, how much charge you've used, and so on. So you have to make some graphs in order to know how much money are you saving or how much money you will produce in case that you want to sell that power. My project was just a prototype. I wanted to show how MPPT works. That's why I've made this PCB. It was perfect? No. It was a real MPPT? No. That's because more than half of the time this type of controller was working in PWM mode because I made this to work only with lead acid battery, which is something like this, which is a battery from a car, for example. And this will have a graph like I can show here on the screen. Basically it will charge in the ramp mode, which is called bulk. Then it will have an absorption time and then a float or compensation time where basically it's almost at the maximum voltage and you only have to keep that voltage in. So in that case, if you want to get more power, you can't, because that's the maximum power that the battery will have. So even if your panels can give thousands of watts, you can put more power into the battery because it's already at maximum point, or it can take that amount of current because it has to go first into a ramp. So what you could do is to add more batteries, but that will increase your costs. That's why if you take a look at the code of this prototype, you will see that it's more like a PWM version than MPPT. But the next version will be only MPPT, actually a mix of it, but it will use a lot more MPPT, so we can increase the efficiency. Actually, I would really like to remake this project in order to measure the efficiency of this one compared with the truly MPPT, and you will see that it will get maybe like 20% or 25%. Usually MPPT is 25 to 30% more efficient. Okay, so this is the prototype I was talking about. And the first improvement is to place 2 current meters instead of just one. As you can see, we have a current meter here, which is the AMS 712 and no, ACS 712, and this is a Hall-based current meter. And the problem with having just one current meter is that you can't really know the efficiency of the device because you can only measure the output power or the input power. But in order to know the efficiency, how much power is wasted inside of the circuit, you have to measure the input power but also the output power. So now we'll have 2 current meters, one at the output, one at the input. And I'm thinking of using a different sensor because this sensor is very good. It's based on Hall effect, so you are not interfering with the circuit. Is insulated from the circuit. But the problem with this one, since it's based on Hall effect and I have a buck converter here, this generates a lot of magnetic fields with the coil and everything, and sometimes we have some peaks of current which are not really there. So I'm not sure if that is the good way to do it. So basically I want to change to another module, which is the INA 21 something and something. I'll place it here on the screen. But this is based on a shunt resistor, which is a very small value of resistance, and with an operational amplifier you measure the voltage drop on that resistance, and since the current is voltage divided by the resistance and you know the resistance, you can get by knowing the voltage you can get the current that is passing. So maybe I'll place that on my new schematic because the PCB that I've made is still based on this one and I want to change that before I order it. That's why I haven't ordered it yet, because I'm not sure is that the correct decision or not. And other changes that this MPPT will have are some big changes for more power. For example, instead of this small MOSFET, which could work up to 55 volts, I want to use some IGBTs, which could handle a lot more power. I think these IGBTs can handle up to 600 watts. And if you have more than one, you can handle even more current than that. And also I want to make an MPPT that will work with up to 102 volts or something like that, because usually when you have a solar panel which is not like a toy solar panel like this one, which will go up to only 5 volts, usually the big solar panels that you are placing on top of your roof can go to up to 24 volts each one, and if you have four of them in series, you can easily go up to 100 volts. And the more voltage you have, the low current you need. So if you have a system of 24 volts instead of 12 volts, you need very small wires, because if you are using less current, the wires could be a lot smaller, so it will weight less, it will cost you less. So if you have a lot of wires in your home, it's better to make a system of 24 volts instead of 12 volts. Oh guys, I wanted to tell you an interesting fact. talking about the increasing the voltage for to lower the current, Tesla, the car company, is the first company, I heard that is the first company who was able to finally decide to increase the voltage of the car up to 48 volts. Usually the cars are working with a battery of 12 volts up to 14 volts, but this time the car, the Tesla, is using so much power with the screens, with the sensors, with the camera and so on, that you will need very, very thick cables. And thick cables equal to a lot of weight and a lot of costs. So in order to reduce that cable, to make it thinner, you have to use a lower current value. And how can you use lower current value? By increasing the voltage. So now the new Tesla, I think the Cybertruck, is working with 48 volts instead of 12 volts. And that also gives advantage because that's the first car to have the steering wheel disconnected from the wheels. Basically it's using motors, this is called a dual drive motor, to steer the wheel, because now it works with 48 volts. That's an interesting fact I wanted to share with you as well. Okay guys, so that's basically how an MPPT system works. I will post these graphs, which are very important, on my website as well. You have to understand that the MPPT will go and make like a trial and error between current and voltage, and it will get like a graph like this one where you change the current and the voltage value and you get the power. When you are on the peak, up on top of the power, you stay there and keep it steady, and in that way you get the maximum voltage. Also, this will be my next version. Have in mind that it will use IGBTs. It will go for 100 volts or even more. It will have Wi-Fi connection, which is very important because I can relate this with my online IoT course and maybe store the values on the database and make some graphs and so on. And it will have a new firmware, and this will be purely MPPT. I will change the code. I'll do my best to make it as MPPT as possible and make some modes for different kinds of batteries. The PCB is ready, but I have to change the current modules because I don't like the ones that are using Hall effect. I will change to some different ones, and I will keep you posted. I hope that you have learned something new about MPPT, and now you're ready for the final project where we are assembling the entire PCB and test it out. I won't go over the code because this is not the final code. I've made some tests with some prototyping on a breadboard, but till I don't have the PCB, I can share the final code and make sure that it works. So when I receive the PCB and assemble it, I'll let you know. Hey guys, as always, the comments, the announcements are at the end of the video. I have a few announcements that I want to make, and the first one is, well, thank you to all of you who have commented on my video where I was whining about that YouTube is not going that well. Actually, that's why I've decided to make a lot more videos like this. Just take the camera, record it without a script because you seem to like that. You get to know me better, we have a little bit of fun, I'm more natural. And that was the first video that got more than 1,000 comments. And I think that was the key because that video also got a lot of views. Because you see, if you comment, actually I had comments where people were commenting to other comments. So basically we're talking to each other. The community was answering questions to other guys in the comments. And I think YouTube saw that, and basically it shows YouTube, hey man, this is getting a lot of views, a lot of attentions, people are commenting and arguing about, so it got promoted a lot better, so I got like a spike of views for that video, just during those days, then it collapsed. So I think that commenting in the videos helps. So if you want to help this channel and you don't want to activate the notification bell because it's annoying, and you don't want to watch all of my videos because you don't have time, at least when you have some time, share this video and comment below. Even if it's just a simple comment or a comment to another comment that it's already there. Thank you very much. I hope I have a lot of ideas to bring this channel up, and this 2024 I have to implement some systems to grow my community and really make a maybe small but very united community of electronics, maybe with other channels, with my forum and the platform, everything I have to change it in order to get more united, because as I've told you, it was very hard for me to see that my post was getting only 10 questions and I have more than 500,000 of subscribers. So basically I have a community that is very big but is not aware of what's happening inside of the community. What I would really like is to get to a day where my own community could help other members of the community, because you see I get a lot of questions on my email, Instagram and so on, and sometimes I don't have time to answer those. But sometimes maybe you have the answer. So if somebody is asking about an ESC project or maybe a battery charging process or who knows, maybe I don't have the answer, but maybe you do. So I want to have like a close and very united community that can help each other. That's why I've made it the platform electrobes.io, which I will reset it from the beginning, play some reCAPTCHA because it's full of spam, and make it better so we will have a better community. Thanks again and keep up, you guys. Hey guys, so that was another project and I hope that you like it. As you all know, to buy all these modules, a huge help from you is from Patreon. So if you want to support me, you can support me there, but also just commenting below, giving me a like or sharing this video, it will also support my channel. So thank you very much to all my patrons and to you guys.